Okay, finally we're going to step and work with rational exponents. A rational exponent is similar to what you guys know as a root or a square root. Now specifically, when we talk about square rooting, we're talking about the second root of some value. Okay? In other words, we're looking for two numbers that multiply to that value. The only thing is, we have many different types of roots. It's not just square roots. Now, up to this point, you guys have only really worked with that. But we can work with many types of root. We can find the fifth root of something, the third root, the 19th root. Some of them get very complex when we do it, but we'll be using our calculator, so it'll be a little easier for us. What I really want us to focus on is this set of formula. Okay? This little formula says that a base to a fraction exponent can be written like this as a radical. So the base goes underneath the root. The denominator becomes the type of root, so whether it's to the square root, the cubed root. So that n is always going to be the radical, and our m will always be the exponent to the outside. Okay, our whole number exponent. So what we're going to do is we're going to try to apply this rule to the very first one we're going to deal with, question A. Okay. Question A. We know that the rule states that our n, b, and m is our exponent on the outside, is the equivalent of b to the power of m over n. So let's figure out what each of these are. What would be considered my m, or my numerator, in the question above? What number? 1. What would be the denominator? 5. Good. So what we're going to be doing with those is that's going to become the exponent on the outside. This will become the power. And what was our base?
32.
Good. Our base is 32 in this question. Okay? So, when we go to set this up now, we're going to be looking for the fifth root of 32 to the power of 1. Well, what's anything to the power of 1? Not 1. Itself. So the 1's really not that important to include here, so we can kind of drop it off. We're going to be looking for just the fifth root of 32. In other words, we're looking for a number that multiplied by itself 3, 4, 5 times will be equal to 32.
No. 2.
Yes, that's right. The answer is 2 in this one. Okay? 2 multiplied by itself 5 times becomes 32. On your calculator, you probably have something like x to the power of y. Y. Yeah, you'll be needing to use those buttons on your calculator. Okay? So that's a simple expression. Let's go to the next one here. Okay? What would be considered my base in this question? Base would be negative 27. Our numerator is negative 2. Okay? Or positive 2, whatever you want to look at it. And our denominator is 3. Now, the first thing we want to talk about is our exponent is actually a negative. So in order to go through this, we want to make these positive. We're not going to be looking for negative roots or negative exponents. So the very first thing we're going to do is change the base up to make this a positive exponent. This will now become 1 over negative 27. Okay? Our exponent will then become 2 over 3. From there, we're going to work with this. Okay? Now, our whole base in this question is now 1 over 27. Our denominator is still 3, and our numerator is still 2. So what we're going to do is we're going to find the third root of our base. Well, the third root of negative 1 over 27, all to the power of 2. This looks confusing because it's a fraction. So what we're going to do is we're going to break these into cubed roots each. We'll put it back as a fraction and find the cubed root of the numerator and the denominator. So what we mean by that is we're going to look for the third root of the number 1, and we're going to look for the third root of the number 27. Sorry, it's a negative 27. And this is all going to be to the power of 2. Okay? Well, what would the third root of 1 be? What number times itself 3 times is 1? It's 1. So we solve that. And then negative 27. What number times itself 3 times is negative 27? Negative 3. Right? Think of it like this. Negative 3 by negative 3 by negative 3. Well, the first two equate to a 9, And then 9 times negative 3 is negative 27. Good. So we know that this term is going to be negative 3. But this is still all to the power of 2. I'm going to have to put both of these exponents to the power of 2. What is 1 to the power of 2? What's negative 3 to the power of 2? So our answer, when we evaluate this, is 1 over 9. The very last thing, I'm going to actually move this one so we have a lot more room to work with it. Okay, we'll move it to the bottom. Okay, our last question, C. Before we go about evaluating any of these fractions, we're going to simplify everything. The very first thing we have is a power of a power, right? So we're going to have to multiply these two powers together. And on the bottom, we're multiplying bases that are the same. So we're going to be adding those exponents together. So when we go through this, the next step is going to say 8 to 1/6 times 7. So we have to remember our multiplication rules for fractions here. On the bottom, we're going to have 1/8, a half, plus a third. Again, you got to remember your fraction rules. Plus 2?
No, plus.
No, it's not, because it's a power of a power. It's multiplication.
Oh, yeah.
Okay? Nice. Okay, so from there, a 6 times 7. Well, if you guys remember your fraction rules, multiplying fractions, we have 1/6. What's 7 as a fraction? 7 over 1. When multiplying fractions, we multiply top by the top, bottom by the bottom. We'll get 7 over 6. So the numerator is going to be 8 to the power of 7 over 6 divided by. Now below, we're adding two fractions. In order to add fractions, we need a common denominator. So 6 will be a common denominator. In order to make that 6 becomes 3 over 6 plus what? 2 over 6. It's going to be equivalent of 5 over 6. So our denominator then becomes 8 to the power of 5 over 6. But we're not done. We still have, because this is a division, we're going to subtract our two exponents. So we're left with just one base. Base 8, and it's going to become 7 over 6 minus 5 over 6. So 8 to the power of 2 over 6.
Can you make that 8 to the power of 1/3?
Yep. So we're going to reduce that fraction to make it even easier. Okay? When we reduce that fraction, it becomes 8 to the power of 1/3, which means we're just looking for the cubed root, or the third root of 8. So the third root of 8. Because technically that becomes the power of 1 outside, which won't change anything. What number times itself 3 times is 8? Anyone know?
2.
2. 2 times 2 is 4, times 2 again is 8. So your final answer there is 8, after all of that work.
8?
Sorry, 2, Sue.
Oh.
There it is. After all that work, from here to here, this is the equivalent of just writing the number 2.
Oh my God.
So there's our entire, whoops, still got the entire page here.
So we have to